Hello, folks. How are you all? Welcome to the seventh session of the Startup Beat COVID-19 series. Uh, to talk about today's session, it's about the minimalism in software development. So minimalism is the art of getting rid of the extras and the focusing on the things that matter. And especially in the time of COVID-19, we all are struggling to what we should be doing, what are the things that we should ignore. So to talk about this, we have Girish uh, from Hair Technologies. Guys, don't go with the looks of Girish. He may look very young, but he has a epitome of experience of 20 years spent in software industry. So welcome, Girish, and I won't take much of time. So over to you.
Thank you so much. Yeah, thank you so much. Hey everyone. Good afternoon, and welcome to this session. So I'll just start with like some a simple introduction to the minimalism itself, and then walk you through on some life-related aspects of minimalism, as well as then jump into some of the how do you apply similar things into the software development aspects. Let me share my screen. Hopefully you're able to see my screen now. Okay. Okay, so you could probably see the minimalism here. A bit of no presentations, but simple pointers, and I'm going to just walk through that. So you could just go ahead and check what is minimalism in life matter, but a brief introduction is like it is a way of living without much much baggages, in the sense you actually focus on what really matters in your life, and many times it may not be a lot of things, but it will be probably more experiences. So you can actually, people focus on experiences in life than what you own. A simple living style, you could, a very good example of Gandhi, or what he actually achieved versus how he looked or how he lived, what kind of things he had to live, kind of gives you an idea of what it means. Another simple rule of, while there are a few rules, probably this is called a 90-day rule. You could change that 90 into whatever you want if this doesn't work for you. But what it means is, like, if you haven't used something in your home or in your possession that is not used for like 90 days, you may want to get rid of that, right? You don't want to just unnecessarily keep it. So that's like how you start living, living that way. So you could find more on this online. There are videos. There is probably a series on this I'm not sure if it's Netflix or maybe in YouTube itself. Now, why is minimalistic approaches are important, especially in probability of, especially in testing times, right? So if you spend a lot of money when everything looks good around you, and it probably doesn't impact you much. But if you do the same thing when you have difficult times, you have not enough income, you're going to be in trouble. So you normally try to be lean on what you're spending. And same. I mean, so everything that we talk about here is towards towards how do you identify what matters the most, and how do you focus on those? And in software development, how do you do that? Why it's important? The simple example is like, the probability of surviving at testing times will be more if we actually follow some of these best practices, and some of these practices which actually makes your life simple. You only buy or use what you really need. So you always focus on what things are, what things matter at that point, and only focus on those. An example of probability, I mean, when I talk about probability, like I read this from a book, driving drunk versus wearing a seatbelt. So if you're driving drunk, the probability of you get into an accident and things go wrong is pretty high, while it may not happen always. But again, the other way around is same, right? So wearing a seatbelt and not may make a huge difference. Not always, but if you get into an accident, probably that would decide your fate. It's basically how do you to highlight the importance of following some fundamental principles and best practices in case of software development. And it's also to highlight, why do you actually do all these things is also, if you're a startup and if you are a startup or any company, actually, if you're running the company, then if you actually, try to minimize what you consume and how do you do things the most efficient, you have you have a hit on your bottom line and top line, right? So you, because of the way things are done, very focused, and the way you expose, for example, if you're working on, I'm already kind of jumping into the software side of it, but if you're working on developing APIs, right? How your APIs are better than your competitor's API because it is pretty thin and easy to use, might give you more customers. That way, your top line would grow. At the same time, the way you write your code or design your software, that will make a big difference in terms of how much you cost. How much you cost in order to run that software. So well-developed, optimized code can probably, run with much less cost, especially if you're using cloud-based, deployments and your systems are running. It all depends on how much machine power you need, how much time how much time you use each of those infrastructure pieces. So it depends on all that. So if you have extremely efficient code that can run faster, you're going to reduce the expenses that you incur on those areas. So that's how you impact the bottom line. Now, more details on software engineering. In software design and development, what I mean by minimalism, or what I really want to say about things that matter. Right. So, been working on in software development almost 20 years now, with starting as a test engineer to developer to leading a team, a principal engineer on an architect, and then building my own team in last 2 years. So with all those experiences on both the people management side and the technology side, I can emphasize on some of the things that I strongly believe and experienced in my my 20 years of time. That's what I'm trying to bring in here. So design core. Software architecture contains software development contains different phases, and one of the primary thing that developers and architects do is the architecture and design and implementation testing of the software. So a well-designed software, the qualities or what really matters in that is reliability and robustness. For example, how is that related to minimalism? Okay, you actually have systems which is not well designed. Then you have issues in running that software at a higher load. You may get into trouble, or the stability goes off. It might the robustness and reliability really matters when you have higher load, when you have if you have depending on how many defects you have inside, or when certain conditions it breaks. So it really matters, because if you actually don't care or take care of that in your designs and in your tests and everything, so it is going to leak into your production environments, and people are going to come back to you. You're going to rework on it, which is more expensive, and you're going to actually lose customers. So that way, both sides, you're going to lose things, and you wouldn't want to do that, especially in difficult situations. So Efficiency is another factor. I kind of touched base already. Like if you're running on an infrastructure on cloud, you're actually paying for those companies, and then if your code is not efficient, you're going to lose out there. So definitely something that you would something I would consider as things that matters for your survival. Usability. Again, if you are normally any company that runs on develops the user interface based the web applications or the mobile applications or APIs. The usability aspect is what drives the customers towards you or against you, and that's definitely something that matters. We'll talk more on like from a design. If it's an API, what is meant by usability and related things later. Same goes with maintainability. So if especially in places where you have people keep on moving, or you have new people joining into the teams, and maybe other people moving out, or your team is growing, so which means more people are coming into your team, joining your teams. In those cases, you would definitely want your code to be readable, easily understandable, and maintainable. So if somebody wrote that code and someone else comes and picks up that code, and that person cannot understand the code, or it's extremely hard to make a change in that code, that's not going to really help. Reusability and evolvability, mostly what do you call so you have certain, you wouldn't want to repeat the code, or you wouldn't want to rewrite things again in some other place. So try to make things reusable. So those aspects are going to again make your efforts less, right? And if you can reuse certain things which is already existing. Evolvability is also like how do you make changes into the system without really impacting the whole system, or how you design your system in such a way that you can make changes into that system more easily. Those are the aspects that matters, and then these are more things on how you would do that. So from a design point, when you actually say design, it means like it's kind of something that I copied from somewhere, an antidote to complexity. So you're trying to so you have to solve a problem, and then you're trying to solve the problem, and that introduces certain. So you're trying to introduce a solution for that problem. Now you have to. So if you want to take care of everything that matters here, when you build that solution. That's where you need a design, right? So you need to basically understand what is the most important parts of this, and when you solve this problem, what all other problems that can get introduced, what are the the constraints of the system and constraints of the technology that you use, to solve that problem. So you're trying to make a balance of all those. You may not be able to use, for example, like you have a use case where you want like high stability for a system, and probably high consistency of data in a system. And at the same time, if you also want like high scalability, that's going to contradict each other, because the constraints, when you need like high data consistency and high scalability, it's not going to go well together, right? Because if you want to have like high data consistency, you need to introduce transactional locks, and make only one person can update certain things at a time. So everything has to be synchronized, and that's the only way you can do it. But then the moment you do that, you actually compromise on scalability, because you actually, especially if you're working with larger set of data sets and you cannot really store everything in one piece of hardware, then everything becomes more complicated. So that's where you need to, that's the process of where you measure, what's the best approaches. Do you really need that kind of high data consistency for a specific use case, or is that like, is it good enough if you actually attain like certain level of consistency, and there is still a place where things can slightly go wrong, but could probably be retried, or those kind of decisions you make. So it involves so if you try to actually make a system which handles both of this, that system is going to be extremely complex, right? So that's where you actually, and once it becomes extremely complex, you're going to actually hit on other aspects of maintainability, usability, probably efficiency, many other things. So it's mostly when you do a design, it's a balancing act between all these things. Take your use case or sub problem and figure out what are the ones which are mostly the most important things out of it. Okay, and now there are so that's about the meaning of design, and then how do you manage the complexity. There are two types of complexities you normally categorize within when you develop a system or when you solve a problem. One is the complexity of the problem itself. The second one is an accidental complexity, or the complexity that gets introduced into the system because of the solution that we choose. For example, a choice of a particular framework or tool. Okay, you use XML versus JSON. So if you use XML, it might have more complexity than using a JSON. Just making assumptions, but you can think so you picked a specific framework, and that framework comes with certain configurations or certain aspects, which is from a problem statement standpoint, it doesn't matter what configurations you use or anything. So it is not directly related to the problem itself, but you introduce some additional configurations, etc., because you chose that framework, and that framework need those in order for that framework to work. So somebody who comes into that, into developing that, they need to know that framework and the configurations behind that framework, which probably has nothing to do with really the problem statement itself. Inefficient state management, and another example, you copy this, you have multiple places in your system where the copies of a certain state of the system is kept in multiple places. So what it means is that this might be accidentally happening, right? It's not probably meant to do that way, but somebody actually put the state in another place, and then you have two different states, and when some of the state changes, there is a good possibility that you might change it in one place and not change it in the other place. So it introduces, that's an additional complexity that somebody needs to take care if that happens. Trying to build future-proof generic solutions. So if you're trying to you're solving a problem, and if you're trying to solve that problem for also considering what you think as similar other problems that can be solved with this, that may introduce complexity, because and at that point you may not even know whether it is really really need to be solved by this. So you might think way ahead and design something which just makes it complex, and at this point you may not need that at all. Failure to analyze the problem itself fully, that's another important aspect. Sometimes there are many situations where you get a problem and you really the problem has multiple problems within that problem, but then we try to solve that as a single problem, and that introduces complexity. So analyzing the problem itself and seeing whether is it just like a one problem, or behind it is it multiple problems put into one one problem statement. So if you can if you can actually identify the exact specific problems, then your solutions can be very focused on those two different problems. Otherwise, you will try to solve the bigger problem, and your system will become more complex because of that. So these are some of those accidental complexities. So when you design things, the goal should be that you focus on managing the essential or inherent complexity in the problem, and minimize any of this. There are things that you cannot probably minimize, because you would probably have to choose one of the frameworks. So make sure that the frameworks that you choose is not adding too much of complexity just because you choose that. And then some of the other parts are very much how do you write the code, how your system is is designed, how do you do code reviews, how do you measure the complexities in the code. Those kind of things will help you to get rid of most of these accidental, not get rid of, but keep it minimum. or not more than necessary to solve that problem. So I mean, there's something that comes out very clearly when you work on designs, software designs. So you start designing, and if you give the same problem to two different people, you would most likely end up with a very different designs. Not to tell that either of those designs are good or bad, but you will. And so there is no one predictable output for that. And in many cases, you will also see that when you actually start with the problem, you have probably no idea how to solve this, right? So you actually have to solve the problem to actually get, to learn how to solve the problem. You actually see that can only be clearly defined by solving it. So only at the end when you solve, you know that this is the way to solve that. So it's not really like, okay, you have a series of steps that you can execute and your design is done, right? It's more intuitive, and it more has to do with the person to person, their experience. So here's some of the things that I mentioned, like rule of thumb, experience and feedback. Sometimes you have to design something and then you get feedback and then you iterate on that, and that's how you get it better, like iterative and incremental. So yeah, the goal is like define the problem and the solve, and then solve it the most efficient way. So the most efficient way is always like, there might be many most efficient ways, but there could be also many bad ways. Okay, so moving into the the development practices, design and development practices that helps you to actually make this design good, or to have a decent design that works well, that meets these qualities. These are some of the items that I put together for that. So evolutionary architecture, it's a pretty pretty popular term that is used especially in agile ways of working for teams that work on agile methodology. So you have like smaller sprint cycles, and compared to like how the software used to be built before, where you had a whole requirement section and an architecture coming from a set of robust requirements. That's not how things work in most of the cases. There are still probably value in doing that in many cases where you have very predictable or very, very stable requirements that doesn't change in long term. But if you have worked on software and technology side, you know that things are changing. Things change extremely fast. You bring some requirements today, and probably like 6 months later, that's not even valid. And if you follow the traditional waterfall models of development, that's how you normally work, right? You actually get a set of requirements, you build the design or the architecture and design, get into development phase, and then get into testing phase, and then deployment. And by the time user sees the first piece of software, it's already probably many months, and the requirements might have changed. So that's today most of us work on agile methodologies where you have on two sprints, or 2 weeks sprints or 3 week sprints, whatever works for each of you. But it is iterative, and I have a separate section to talk about more agile part of that. I'm just talking about the evolutionary architecture part of it, because that goes with agile, because you're working on smaller increments. So you have no base architecture to start with. So you need to start you need to start building the software, and your goal is to get something working on a simple function or a simple functionality, a base functionality, to get that working and get it tested and get feedback from that. So that's your goal. So your architecture has to be evolving, rather than you wait for like a complete architecture to be ready and then you start working, right? And these are, there's a book that I've mentioned. It's not a book, it's actually a link I've mentioned here. You can actually see more explanations about fitness functions. Last responsible moment, bring the pain forward. Fitness function is something of this sort, like how does each of this actually applicable for your software or your system. So you actually, that by knowing that, you know that which are the architectural parts that you need first, or you need to focus on, and which ones you probably can delay or not take a decision right now. A related thing is also called last responsible moment. This is you usually when you start to build something in your first sprint, when you develop a product, or develop a new feature, whatever whatever you start with, and you most likely wouldn't have all the requirements. You would have some basic requirements, and then the way agile work would be that you go back with that implementation and then get more feedback, because the user now can see how things are, may have more feedback, they may have more clear idea how things should be, rather than they imagine everything on head and then try to give us a full set of requirements. So you're never starting with like 100% requirement. Sometimes you're starting with like 50% or a way less set of requirements. So the problem with that is that you wouldn't be able to make architectural decisions in using those, right? You don't know the full picture. So how do you make architectural decisions? Usually architecture is considered as like things that you can't change easily in a long term. That's what you call architecture pieces of the system, right? So if you don't know all the requirements, how can you tell that? So that's where so there's this concept of last responsible moment is like, if you're an experienced person in software development, you normally would have you would normally see that, okay, I have this much of requirements, I'm going to put together these things that is mostly required for these features, and these features as my architecture for now. And then there are certain things which you need to decide on, but you don't have enough information to decide on, and you may not need to decide that right now. Right? So you actually delay those decisions. So but then there is a point where that beyond that point, say you ran 2 sprints and then you got some feedback and you have more information now, and then you need to add more features into that as well, right? So there will be a point where when you try to add more features, you will actually see that, oh, you know what, this part of the system which we didn't make a decision yet, now has to be decided, because if we don't decide it now, we cannot probably implement this new feature. And then you go back and see, do you have enough information to actually make that decision now? And because you already ran 2 sprints now and have feedback, everything from from the users or from everybody who is part of this, you may be in a position to actually make that decision now, right? So most likely that's how it works. And mostly you would have that. If the user wants a particular feature, a new feature, and that needs you to make a new decision on the architecture, most likely by the time you would have that, enough information to make that decision. And if you don't have, then you would probably have to go back and delay that feature implementation. Or it's more of, I don't think there's one solution for that. And again, the last responsible moment is not just a fixed time. It's more coming from your experiences and what you know about the system, and what you actually what are the best practices and all those things. Okay, one of the one thing that makes evolutionary architecture very very feasible is actually microservice architecture, and this is microservice architecture enables it because it is more loosely coupled, and everything is tied together by contracts, and and you can actually replace one of those internal implementations with another one as long as the contract doesn't change. If the contract changes, yes, you need to make those modifications, but it is more loosely coupled but still cohesive, and you can make distinct architecture decisions for each of those components, but overall your architecture itself is like a microservice architecture. Now, in terms of implementing your design or even designing itself, these are some of the basic principles that many of you who work on software development would be familiar with. Keep it simple and stupid. Yagni is, you are not going to need it. Right? There's another example, we talked about already, about that, designing for future. So if you're thinking too much about future, where you don't really know what exactly, but you feel that these are the things, don't just do it. That's what it means, right? You're not going to need it. When you need it, you make the decisions. So don't over-engineer, or don't try to engineer for too long of a future. Dry is do not repeat yourself. Don't duplicate code as much as possible. There are some places you maybe these are all guidelines, and there are exceptions. It's not to say that this should be the case, but these are the ones you need to make that decision whether you want to really repeat some code. In some places it may be like few lines of code, and generalizing that may be too much of an abstraction. Then you should probably not, and you repeat it, but don't repeat things which are used like 4 places, and it's kind of 100 lines of code copied everywhere. That's pretty bad. Solid is a set of principles that you can go through. There are many videos in YouTube if you're not familiar with extremely important guidelines. 80-20 rule. Many times when we develop we have a set of requirements, and then users see things, and then they actually come back with feedbacks. You get additional stories to implement many things, but there is a point where you will actually have to make a decision on whether you want to really, implement all those stories or not. Do you want to give all those features that users are asking for? What's the value that you get out of, the user gets out of it, or the customer gets out of it? Is it important, and sometimes you will have to measure that against the complexity that introduce you into the system. So if your last 10% is introducing like 10 times complexity into your system, just an example, you probably wouldn't do that last 10%, because especially if you have if it doesn't add like that great of value. So that's how you say like no for some of those requests and stories. And otherwise you might add something which is very it adds certain value, but it's very it doesn't probably matter, or it's compared to the complexity that might introduce and effort that you probably need to put into that, and how it impacts the maintainability and everything, you may say, okay, we're not going to do it, or you may have another way of doing it in a much simpler way. So you choose those. Other mechanisms around the abstractions, information hiding, encapsulation, layering. Those are again techniques that helps you to have clean designs, which can actually help to maintain maintain the code pretty well. Abstract interfaces hides implementation details and complexities. This is a simple example. I don't really have the code here now, but I think I can explain it. Like a student and a course, student registers for a course. So there's a class course, and then there is a class student, and then you can set a set of students into that course. Now there's a method called set students. That's one way of implementing it. But you could also implement it as like add a student to the course, or remove a student from the course, or you could probably call it a register for register and unregister, whatever makes more meaningful. How would you probably do that in real world? Use those terms, and that's an advantage, because if you keep it as set, it's probably a very open interface. Anybody could get that and then set that back, which means it's replacing the internal state completely from outside. So it doesn't really have a specific meaning. Anybody could just set a set of students into a course, but the other one is more meaningful name, so it's easy to read. And if you say that add a student to a course, it is that a student or a set of students, it is adding on top of existing students which is already registered or added. And remove is you're removing from that list, so it's more controlled, and it's the internal parts are the data is hidden, the actual state is hidden, and you're not directly allowing to change the state, but rather you're actually having very meaningful interfaces which tells what it means when you add and what remove. And sometimes you won't even need documentation for this, because it's pretty obvious. If you think about like abstraction and the information hiding, encapsulation, all this goes together as like when you say abstraction, it is mostly how do you decide what is your interfaces, right? So you abstract your interfaces, so whoever works with that problem has to handle with a clean set of, has to only work with a clean set of interfaces rather than you knowing exact details of how it is implemented. So it's more of, more of what is offered by that interface rather than how it is implemented. So those who use it just need to know, those interfaces. And encapsulation is the other part where you actually implement it, where things are hidden, where it is not necessary. So the details are hidden behind the implementations, and it's also encapsulated in a way that it is cohesive, and it's not. I mean, it is cohesive in the sense things that's supposed to be together are together, and things supposed to be different are different implementations. Abstractions, and you can see this in many technological development, like how we actually started with what do you call the vacuum tubes in a room for a computer, which probably is like a calculator size, calculator function. And eventually that was, those were actually, the complexities of those were like compressed, hidden, and APIs exposed around it, or interface faces around it. And then you actually stack those into many number of times in nano level, and then that produces an IC chip, and then you have a chip as an interface or a way to talk to the chip, and that produces the larger set of what do you call the computers itself. Then on top of that, you have like programming languages, and you can later you got APIs like web APIs, or what we now use as REST, or on top of that, you actually got things like cloud computing, which is actually using APIs in order to allocate resources or allocate infrastructure. And now you have services running on top of that. For example, if it's Here Technologies, we provide location service and location APIs. So the location service adds. So we use our map content in order to decide. For example, if you want to find the route between A and B, how do you do that? How do you do that is like something that we expose an API, so you don't have to worry about finding a map data and then finding an algorithm to do that. All that is hidden behind that. Locations, I mean, so same way you can actually see that there are more services which are built on top of location services, like the cab aggregation service, and then you have services on top of that again, which is like from Google you can actually book any type of cabs. So there is a cab aggregation service interface itself, which is which is on top of the location services. So you can see how complex problems can be solved by abstracting and having clear interfaces, exposed for your own problems. Composition, and I'm going to probably run a bit faster. Okay, composition and coupling and cohesion. So the way we build normally applications is you have, you don't just write an application as such, but you split your application into a number of things, like it should be built with a framework which holds the components together. So you have a set of components which is more or less attached to the framework, and then you also have libraries where you can simply reuse those libraries with much of no dependencies with any kind of frameworks. So the components might use libraries, the application might directly use libraries, and application is built using the components and libraries together to build a complete application. And you could actually reuse some of these components in other applications which has a similar which uses the same frameworks. A car as an example, I mean, if you take car, it's actually assembled with many different parts, right? So you can actually go to a what do you call it, a hardware store, and probably get a specific. If you specify the actual model and number and specifications, you could probably get a part of that car which guaranteed to be fit into your car, and can simply replace that part when that goes wrong. So you see the interfaces are pretty clearly defined. That's why you're able to specify the numbers or the specification to somebody and get that replacement. So you may want to think things like how you build a car, the same way you build a software component. Yeah, I mean, overcome sunk cost facility, probably not that critical, but yeah, sometimes we make decisions because we made some investment in the past and we don't want to get rid of that, or we are holding on into that. Maybe if you get rid of that, you probably save a lot for the future because you may have a better solution. Use libraries, open source available libraries, rather than you writing the code if you already know that there are things which which already exist in open source market. Or sometimes you might have already written some code, but an open source library may be providing you more functionalities, which you may need, but because you wrote some code, you shouldn't probably holding on to that code, right? You should actually be replacing it with an open source library, because that's more tested, more people using it, so you know that probably it has less bugs and you don't have to maintain the code yourself. Test-driven development, extremely important, given it's not only going to help testing, but it is actually going to drive you to a good design. When you drive things from top, like you start with what is your functional use cases, or your use cases, and you try to define the interfaces for those use cases, and then when you implement, and then you write the test against those interfaces, and then you actually implement it. And when you implement that, you would actually find that, okay, this is a pretty big chunk of class or a implementation. So you actually try to write methods or a sequence of steps that you want to perform within that, and when each of those sequence of steps can further be implemented by another interface, define an interface for that particular step, and then that interface implements its own way of implementing it. So it's kind of, now everything is interfaced with those interfaces rather than directly coupling, so you can actually replace the implementations when you have better implementations available, or for whatever reason. And there are situations where you have to do the top-down versus you need to just write some code and test it out and see how things work. That's very common also, especially if you're working on things which are unknown, right? You don't know exactly what interface you need, and you don't probably know how exactly to implement it. But what I would do is that you would actually do a spike or a POCs or whatever you want to do in order to prove that, or in order to get more clarity on it. But then don't pull that code as it is into your actual production code. Rather, you go back and come from top down, and now you know that this is the details, and so you define the interfaces, and then you implement it. You might reuse some of the code you wrote in the POCs and spikes, but don't reuse it as it is. So you need to still split your code into the right methods and stuff, and then use it. Another one is measure design and code quality. You have tools like Sonar and similar code quality reports, and you should look for cyclometric complexity measures, code coverage, vulnerabilities, potential bugs. You have tools to actually look at all those things, and when you maintain all these pretty good, that's where you really get a big advantage of simple designs and maintainability, everything which eventually leads you to actually survive better in difficult times. Another one, DevOps culture. You need, if you build something, you should be able to put that into production in minutes, right? And minutes to hours. And you should be able to do it multiple times a day if that is necessary, especially say you're running first sprint, you have certain things implemented, you want to show that to the user, you should be able to do it in put it in a production where it's alpha or pre-alpha or whatever, and then you get the feedback. But you should be able to make some changes in your code, get it reviewed, committed, and then push into production and get feedback within hours to days, not more than that. So if you're setting up projects, and if you're working on projects, and if you have projects which are not going in, you are not in a position to deploy into production very frequently, that's a big bottleneck for you to get feedback. Moving into, okay, so I'm going to probably take 5 more minutes and then open up for questions. Okay, on the other part, so this is whatever we talked here in the left side is more of from a design and technology side of things. This is more of agile, and I don't want to just go through all of them. I'll just highlight a few things which I believe are extremely important and more or less now coupled with what we talked in the technical side of things. working software over comprehensive documentation. We talked something about like evolving architectures and stuff. So you're not trying to build a whole architecture documentation first, right? You're trying to get working software. Customer collaboration over contract negotiation. Yes. So if you want to do this, you need DevOps culture. You need like continuous integration, delivery, DevOps metrics. All those things are important for enabling this part of Agile. Customer, this part of Agile. Responding to change over following a plan. Again, if you get feedback, you can actually change things, or you might have customer coming and telling you that things are changing, so you should be able to do that. And that's where, again, evolving architecture and all those would make those things much easier. Again, none of these are like all of that says that over, not really, at the cost of, you don't have to do it. I mean, it's not to say that you don't have to do the other side of it. You have to do documentation, but make it minimal. Don't duplicate the documentation in the code and in some other place, and the other way as well. Make clean, good documentations with visual representations of your systems. Responding, so that's primarily that, the values of Agile part. And in the principles, early and continuous delivery of valuable software, again, feedback, harness change, deliver working software frequently. Business developers must work together. Fine. Face-to-face conversation, which is probably not possible right now. Working software is the primary measure of progress. Right, so your progress is measured by working software, how much business value you add into the product. Maintain constant pace, which would need all of this in place if you want to, to do it the best way. Continuous attention to technical excellence. Good design enhances agility. Right? It's extremely important, one of the most critical, and these are all applicable here. Simplicity. Again, the art of maximizing the amount of work not done is essential. You see the 80-20 principle that we talked about here. It's to identify that you don't have to do everything that is there in your backlog. You need to maximize the amount of work not done. That's what keeps you lean and and focus on what matters. Okay, now there's some of like personal values and team values that I normally kind of work with my team or whoever I work with. Be proactive, begin with the end in mind, put first things first, think win-win, seek first to understand and then to be understood. Make sure this is, extremely important if you're attending meetings and discussions. Don't jump the gun and start talking without really fully understanding what we are talking about in those discussions. Synergize, sharpen the saw. Extremely, these two are my favorites. Sharpen the saw. So you need to continuously learn, continuously keep up to date, and make sure you understand before you actually start responding. Some of the books to read: 7 Habits of Highly Effective People. These are nothing direct, but directly from that book. You have pretty good 5 minutes to 7 minutes YouTube videos, which kind of explain some of the examples of these. You should look at those. Man's Search for Meaning. So it's kind of, I put it here because it's a tough book about the author actually surviving the concentration camps and what keeps him, moving. And when you say meaning, that's what probably matters. So read that. It's a pretty good book. And New Earth, it's more of a philosophical or more of a book, but it's kind of helps you to understand your egos and how do you keep it down and how do you work well as a team, or not just a team. It's more of like a life lessons. So to work with anybody, to live with anybody, it's more of that. Okay, with that, we have 10 minutes for questions. I'll stop my sharing. Or maybe I'll just keep the sharing.
Thanks, Girish. So we are open to Q&A now. So I'm sorry, Girish, I will not be able to raise questions because being a non-techie, I don't have, so most of the things were above me. So in terms of the understanding
Okay.
part, so I'll not be able to raise any question.
Okay, I can.
So
Okay,
open
fine.
to
I can pick
the
some of
audience.
those.
Yeah.
So I'm going to. I don't really see any much of a questions here. Can I increase the font size? Oh, there were like requests to increase the font size.
I think the presentation was so much in depth that people are through the whole the whatever you said, people are all through that. So it was a very in-depth discussion, topics that you picked up.
Yeah, so if there are questions, you can reach out to me. I mean, I think my LinkedIn profile was there, and I will. I'm hoping that this recording would be shared as well.
Yeah, the recording will be available. So
okay.
Yeah, so it will be available on website.
Yeah, and I can share the content that I just shared or I used here.
Sure. So those who want to have the content, they can drop us a message, or they can write it here. We will share the content. So we have got a question. We are a financial and a business consulting startup. What are the key considerations while implementing security policy in software development?
Okay. I'm not sure if I can just answer like that. I would have to probably go back and think about it. Can you actually get that, record that question, forward it to me? I can get in touch with them and help you with that.
Yep, I can do that.
Yeah, I may not have like a straightforward answer for that here. It depends on probably many factors, before you can consider it.
Okay. So would you like to take all the questions offline, or this is specific to this particular question?
Oh, okay, I can actually see. I was wrong. I was actually looking at the wrong place probably. Okay. Can you please refer? So I see two questions. Can you please refer any startups or individual software developer who was able to make websites quickly? We have an immediate assignment. If unable to answer this over this webinar, then please. Okay, I can actually give you some hints on like how you can quickly develop a website. So there are like templates. There is a I can't remember that name of that, but I can actually share with that team what that is. So there's quick ways of developing a template, template-based website. You can as like a standard project, and you can quickly add things into that. I'll share those details to those who are here. So do you want me to note down these, or you're going to send me the questions?
I will send you the questions. So
yeah, okay.
Thing, do you want all the questions to be taken online or offline, or there are questions you would like to take here also? Because I think when you share here, when you respond to the questions here, it goes to the larger audience. So maybe a couple of questions you may like to take it from here. So a question like, can you share some of the good source of learnings for the software architecture design?
Yeah, I see that, right. So again, I don't really have so one of them is actually shared in this, in this link. So it will be there. So there is a book also written by the same. So this is actually a blog, and then there is a book on microservice evolutionary architecture. So that's I haven't read it myself, but that's it is written by some of those ThoughtWorks leaders. They are the gurus of architecture. So I'll forward some of those things. So there are many books. I haven't really read like one book to learn architecture. A lot of things in architecture comes from your experience, and I can tell you some of the architecture patterns. That's what you would normally want to know about, right? You have microservice architecture patterns. If you have heard about things like event-driven architecture, that's another pattern. Sometimes you actually combine these patterns, like event-driven microservice architecture, right? So you have other queuing systems and synchronous messaging, not synchronous messaging, like REST itself is an architecture pattern, or MVC, like which is normally the model view control. That is normally considered as an architecture pattern. So I mean, you have many of them, and it is not that you need to. I mean, what you need is to know the architecture patterns and how you choose the right patterns for the problem that you're solving. I will again share some of the books which I think is useful, but you also would want to use like the what do you call it, the YouTube or any of the kind of more of streaming resources that is available on your hand, because you may want to, if you want to like quickly understand the principles and the fundamentals, you may have like so many of these available in YouTube, right? And then you go probably and read the book so that you can actually solidify that understandings and have more context around it. But if you just start reading if you just start reading the book without having an exposure to software development much, at least like few years of exposure, you may not be able to correlate the content of the book with your, what exactly it means. But if you have worked on software development, then you can actually correlate all these, why this pattern, and when you say why this pattern, and when that's explained, you know more about, oh, okay, I know why it's, why is this important. So you'll be able to correlate more, and otherwise you're going to read a book and then forget that after some time if you don't correlate things. More questions?
Yeah. Maybe a good idea would be I'll pick these questions up from here and I'll send you those questions, and you can also add some of the YouTube video links to that, maybe which we can share with the attendees and those who have raised these questions, and we'll send that to you all our audience.
Yeah, sounds good. I think we should. I will do that, and then you can actually send it to all the attendees, so we don't miss out anybody.
Okay, thank you very much, Girish. I am sure people have enjoyed a lot, and I think I am seeing a good number of questions coming up now. But I'll collate all the questions. I'll send it to you, and we'll wait for for answers to the questions. And please do share your recommended links, your YouTube links, your recommended books that these guys can go through, which can help them going forward. Thank you very much. Yeah. I hope you enjoyed too.
Yeah, I'm sure I enjoyed. So hopefully everybody. Thank you, everyone. Thank you for your joining the call.
So any last comment from your side for today, considering the tough time all the founders, all the startups are going through, because the series is designed in a way that we want to support and all the startups in every possible manner. So any closing comment from your side?
Yeah, so everything that I talked about, like I said, if you don't write good, if you don't write solid applications and reliable and solid and follow those practices, usually when things are good, probably things would still work unless you write it really bad, right? But when things are bad around you, the theory is that the fittest survives. Right, so these are the things which I talked about, is to make like pretty high quality software that can lead to your customers to be pretty happy and get more customers, and also to maintain your costs very low, so you can run in a thin what do you call it, payment that you need to make to your cloud services or whoever, right? So those were the fundamental drive for me to talk on these things. So hopefully, that's a message I want to give. Keep these things on your, if your teams have to really focus and understand these things, and that adds a lot of value and flexibility when you develop software and in the system itself, when you follow these things. Otherwise, you're going to really suffer when you have high quality competition.
Great. Thank you, Girish. Thank you very much. And stay safe.
Thank you so much.
Thanks.
Yeah. Everyone take care. Bye-bye.